Hello and welcome to our video on transformation and symmetry. And so this page is all the definitions that we are going to talk about today. And so first thing is the image is a copy of the pre-image by moving it all the points of a geometric figure according to certain rules. So we're going to talk about those certain rules, how we're going to move these and stuff. So the key is the image is the copy of the original image, which is what we call the pre-image. Transformation is the process of actually moving. So when we're talking transformations, we're talking about all kinds of different movements of the geometric figure. A rigid transformation, sometimes called an isometry, is if the image is a congruent to the pre-image. So if you get the exact same picture back, that's considered a rigid transformation. And today, the three down here that we are going to talk about, translation, rotation, and reflection, are all rigid. Are all rigid transformations. So the non-rigid transformations are when they do not preserve the size or shape. Basically, if you had like a triangle and then you enlarge the exact same triangle, that would be a non-rigid transformation. So then the three transformations that we're going to deal with are a translation, a slide. All the points of the pre-image move the same distance along the same path to form its image. So basically we're just sliding the object across the plane. A rotation is when we turn the figure around a fixed point, and most of the time the fixed point that we're going to use is 0, 0. And then the reflection is when it's just kind of like in a mirror. We're going to have a line that we're going to reflect the object across, so it's like you're going to get the reverse operation of it. So let's illustrate these rigid transformations. And so we have this right here. This is our object that we're going to move. And so a slide, you will see, does not change the object at all. It just changes its position. So if I slide, you can see I'm sliding it this way. And I'm going to slide it so it looks like that. And so you may notice that if I was picking this point right here as one of my x values, it is 1, 2, 3, 4, 5 over and 0 up. Well, with this slide, you'll notice that that point is now over here. And so it is 1, 2, 3, 4, 5, 6, 7 back. So what I would say is for the x values in this, it would be x take away 7, because that is how much I moved from the original position. This is my pre-image. And this over here, the colored thing, is the image, is my copy. So I moved it back 7. My y value didn't change any. It's still at 0, so then that would be y for that case. And so you'll notice that in this one, for this slide that I have here, I just moved it back 7 and didn't move it up or down any. And all the points remain that. If I picked this point here, count back 7, 1, 2, 3, 4, 5, 6, 7, you can see I land on the other point. Well, that's not the only way we can do these. If I keep my image there, or keep my pre-image there, and actually move the image, let's try moving the image this way. So here's my pre-image, and this time I'm going to slide it so that I get something that looks like this. And so now this is my image down here. And I can pick any point on here to figure out how it's slid. And so I'm going to use the point up top. And so the point up top up here is 1, 2, 3, 4, 5, 6 over. And 1, 2, 3, 4, 5, 6, 7 up. So that's the original point. Those are my x's and my y's for that point. Well, how did my image change from my pre-image? Well, you'll notice that from this point, if I go to the same point, I went down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my x value, did it change any? My x value still remains 6 from the origin, so my x didn't change any, but my y, I would be subtracting 10. And you could add if I would have moved it. If I would have moved the object to the right or moved the object up, you could add. I know both of my examples I subtracted. So there's from my image to my pre-image, I could see this is a shift in y. Now it doesn't just have to be one movement of x and y. I could, for my image, I could move it x and y. And so if I did something like this, and we said that in our pre-image this point was still 6, 7. That didn't change any. Now to get over to that same point, I went 1, 2, 3, back 3 in my x, and up 2 in y. So then how my translation worked is it would be x minus 3, y plus 2. And so that is how that's if we move it 2 directions. And so that can happen, and that's just basically all the different possibilities for our translations. Rotations, on the other hand, we're going to do 4 types of rotations, basically. One rotation would be 90 degrees, and for the most part, we do rotations counterclockwise. So if I'm going to rotate this one, the object would look like this, and it would be a 90-degree rotation. You can see how my image, which is over here, my pre-image over here, and my image is now changed by a 90-degree angle. So when we do a rotation, there is a relationship between how the ordered pairs change. And so we have the ordered pair, and this point was 5 over 7 up, and I miscounted last time. Maybe you can figure out what this point is over here when I do a 90-degree rotation. Or you might even want to find out what the point is when we do a 180-degree rotation. When we do a 180-degree rotation, there's a relationship to the original pre-image. When we do this, this was image number 1. This would have been image, I'll say number 2. And so these ordered pairs, where these guys are, and in a rotation, will have the same effect for every 90 degrees that we turn it. And so then if I do another 90-degree rotation, that all the points in there, and I'm just picking one point just for the sake of time and argument, that this is image number 3, and so for the sake of time and argument, this is where it's at. And so maybe you could figure out how these points are related to the original point that was given. And then you can see if I rotate it 360 degrees, I'm back to where I started. So this was a 90-degree, image 1, image 2 was 180, image 3 was 270, and there's a relationship between each one of these points with the original pre-image. So then finally we have a reflection, which is what we consider a mirror image, and this thing can be reflected 2 different ways. Let's do a vertical flip first, so we're going to do up down, and so now you can see in this one that this reflection, my vertical reflection, the points switch. I had my pre-image up here. In my pre-image, I'm still using the point of this as a 5, 7, and then my image, which is the one that got flipped vertically, and I'm sorry I messed up the graphs here a little bit, but the image now is this thing down here, and there is a relationship to the reflection also of how the points x and y. And so just like in the previous one in the rotation, I was asking you guys to kind of figure out what the relationship is when you did the rotation on the x and y for each 90 degrees. I want you to also look at how the image when you reflect across the x-axis, how that point appears also. And so there is a relationship between all the points when we do this rigid transformation of a reflection across the x-axis. So you could just test this one point and figure out what that is. And then that would be image number 1 down here. And so then if I go back, and I got to flip it back to normal first, up, down, get it back to where it was. And then there's also a reflection across the y-axis, which would go left, right. And so then you could see this one over here, and I could pick any point. But when I go across, this was image across the x-axis. And then this is the image across the y-axis. And when you do that, there is a relationship between the ordered pairs again, and so basically we need to kind of figure out what those are. And so in your notes, that would be a good thing to try to figure out so you kind of have them. We will talk about them in class, but when you come out of class, you need to make sure that you understand these relationships. So remember, if you have any questions on any of these topics, please come to class with those questions so that we can talk more about them.